Good afternoon, and I'd like to thank the organizing committee for inviting me to speak with you today. So we'll get right to it. See if I can make this thing work. Is that the right one? There we go. Okay, so this is just some of the points that we'll be going through today. Start out with risk, and then I'll move on to some other areas as well, and how do we prepare ourselves to make sure that everything we do with regards to the patient is looking out for their safety and maintaining that safety throughout the entire examination. So as we all know, right, the risks are due to B0, B1, and the gradient magnetic fields. And very basically, metal in being exposed to a magnetic field can do one or more things, as you see there, either move due to the change of the magnetic field that causes things to be pulled into the magnet. Things that maybe that are elongated metal items will attempt to align themselves with the magnetic field or torque. Things obviously can heat in the magnet, heat hot enough to cause burns, and also cause artifacts and images and data. There we go. So the B0 risks depend on this list right here. Obviously, the strength of the static magnetic field, magnet design. And we first saw this back when vendors went from a long bore magnet to a short bore magnet, which changed this spatially varying magnetic field. So the gradient was actually steeper than it was before. And many of you who experienced this change, maybe when we wore pens or pencils in our shirt pockets and we would get close to a long bore magnet, the field was not as strong at the controls, and then the minute we went to the short bore magnet, all that changed. And so now we're taking a closer look at this, and it's even coming into the conditions for medical device manufacturers. The degree of attraction is dependent on many things that you see there: mass and geometry, how it is retained in the body, what kind of tissue is it in, where is it located in the body, is it near a large vessel or is it on the periphery, and how long it has been there. And also we have to take into consideration the operation and the function of something. If you have a medical device, for example, that is held in place by a magnet, then that could make it obviously more dangerous. One thing I have to call your attention to, I'm the editor for the SMRT home study, and Dr. Frank Shellock and Dr. John Cruz kindly allowed us to use some of the chapters from this book in a recent home study, and one of the ones was from ferromagnetic detection devices, which I know is sort of, lots of people have different opinions about it. But interestingly enough, in this one chapter taught me more about B0 risk than I've known my entire life, my entire experience in MR. So if you have a chance to get a hold of either the SMRT home study or this book and read that chapter, it really was an eye-opener for me. So it really gave me some additional information about which came first. With regards to B1 risk, this heating is very, very serious, and towards the end of this talk I'm going to hit more on that, because I think that there is more injuries that are occurring to patients because of this and less injuries that are occurring due to the B0, and I just don't think that we put enough training and education and accessories for technologists and radiographers to use to ensure that their patients are safe. I just think that the risk is huge, and there you can see it's sort of different items that you see here that result in these burns. I also keep hoping there'd be more research. I'll see more research at this meeting in these areas that will help us figure out how we can be safer in our magnets, in our use of magnets with our patients. There's focus in an area. Some people call that an antenna effect. There's currents that can be induced in conductive devices, as shown very nicely in Dr. Kugel's talk previously. This cable or human that touches the bore wall, and somehow there is a current induced. The always popular inappropriate use of an RF coil. I work in a research institution, so I'm constantly working with my students on how not to put the cardiac coil inside the head coil, because it's really not going to work all that well, and it's dangerous. And another one that we see quite a bit, I think, in clinical facilities is this use of MR equipment, monitoring equipment in the magnet room with the patient that is not safe. It's not designed to be used in a magnet room with a patient that's in the magnet magnet bore, and I'm not sure if people are just trying to cut costs or what. So here we see some focus where a child was burned. They came into the MR examination and they had electrodes left on their chest. This person had the ring around the head that was not MR safe. These weren't designed to be used inside the magnet, the stereotactic here. And these were both as a result of using a piece of equipment that was not designed to be used in the MR magnet room. It was not designed to be used with a patient that was in the magnet itself. Anyway, so in going to the gradient magnetic fields, there were some, I think, in the beginning when we all knew about the right-hand rule, many of you who are X-ray technologists, we thought with this changing magnetic field that we would see more burns due to induced currents, but as Dr. Kugel showed nicely, it's really the RF that we have to be concerned about. The auditory effects are real. You've got to provide hearing protection for your patients, and our facility, we have many different designs of earplugs to make sure that they fit well. And then for any imaging that we do below the brain, for example, we always use the ear covers as well as the earplugs to make sure that there's adequate hearing protection. Peripheral nerve stimulation, as was mentioned before, is not dangerous or long-lasting, but it can be very painful. My director and I, when we first got our first short bore magnet, we did a lot of testing on each other, and we're not all that different in body habitus, but it seems he turns out to be very sensitive to this slew rate and to peripheral nerve stimulation, and I am not at all, and we're not exactly sure why, but he told me I was insensitive. Anyway, moving on. Required education and training is really, really important. I just can't stress this enough, and I think this is a lot what Dr. Canal was talking about, is training and making sure that your technologists are adequately trained, and also that the radiologists are adequately trained as well, because they're the one that are going to create the policies and procedures and implement them and support them on an hourly basis. And there's a lot going on, and the scanners are just getting more complicated and more complex, and they really need to know what they're doing. So it's really, really important, as he talked about, having the safety officer and the safety expert and the safety medical director, just really, really important. I just feel like I'm so fortunate at my facility. We have a safety committee, and it's made up by a radiologist and a medical physicist, both who have extensive training and years working in MR. So that's really, to me, sort of the perfect way to go, and I'm glad to see there's being more focus being put on this, especially by the new group, the ABMRS. I think that will help. Hopefully people are keeping up on their reading, and this is a document that you just need to know it very well, and make sure your administrators have copies of this so they understand. I think it's helpful to make sure that people who write the checks and are able to get the training and whatever safety accessories and devices that you need to support and try not to cut corners, that they really need to be aware of the dangers involved as well. Moving on to screening terminology, and Dr. Kugel went over this as well. Very important that people understand this. It's all very important as an MR community that we're training each other. And if you go to a device or implant manufacturer and you see they're still using MR compatible, you really got to send them an email and say, this is out of date. It was what, how many years ago? That was 2005, I believe, that they changed all this. So they really got to get on board, and we've really got to correct people. And I often find myself correcting people and explaining to them that again, that MR conditional does not mean MR safe. It means, okay, now you're faced with going and finding those conditions under which you can safely scan that patient. And so these are just an example of some of the conditions. There's other ones that you'll see, new parameters that you'll see in addition to SAR. I'm just hoping that we're going to get the education, because a lot of those are even over my head, that I've seen come recently, B1RMS and some other things that you'll see that will be on your scanner to let you know about heating. But I really hope that we'll have good education so the technologists will understand clearly how to interpret these things with regards to the safety of the examination. Things even like RF coil, there are still technologists out there and radiographers that don't know how their coils work. They don't know if they're transmit receive, they don't know if they're receive only, so it becomes quite difficult without this training and education for them to understand and try to interpret these conditions and work with their radiologist so the radiologist can make an intelligent decision about whether to undergo the scan or not. With regards to screening procedures, this is sort of the way we handle it at our facility. We try to do as much early screening as possible, so we're not faced with someone that comes with some complex medical implant or device on the day of the scan. We also make sure that even though they go over the screening form beforehand, that they're going to fill out that screening form on the day of the scan, and to make sure that it's current and that they haven't gone and had a pacemaker put in the night before. And really a critical one, and I've seen this at other facilities too, where they have them fill it out, but no one sits down to review it with them to make sure they understood how critical, how important this form is, and to make sure that they understood all the questions. We take a lot of time. We have our patients come a half an hour early, and a lot of it is to go over this screening form and make sure that they're very safe and that they understand how important it is and that they understand all the questions that are on it. Again, even after that, we do visual and verbal screening and get very comfortable with talking to the patient and touching the patient and making sure that before they get into the magnet room that they are absolutely ready to go and safe. Also, screening needs to be done by a qualified person. We now have a PET MR in our facility, and I'm faced with fellows over in the PET department, over in the nuke med department, that they're doing the screening, and we're still working on this because we intermittently get patients over at our facility that aren't quite ready to go, and then we have a lot of legwork to do, and I'm sure you're familiar with doing that and trying to find out if some medical device is actually going to be okay for you to be scanned on your scanner with your scan parameters. You should have comprehensive printed form, and there's a lot online that you can download to use to help you get started. Again, the patient needs to fill them out before every MR exam, and I know there are facilities that if they have one scan one day and they go the next day, they don't have to fill one out, and that makes me very nervous. And even for when we're scanning each other at my facility, we still have to fill one out as well, just to make absolutely sure. And as always, a previous MR scan does not guarantee safety, and I like to remind people of that. So this is just an example from Dr. Shellick's website. He has a 2-page screening form there. You can download that. You can also download screening forms in other languages, I believe in Spanish, and I'm not sure exactly at this time what else. But then you should also have a shorter version for people that are going to go and work on the lights or whatever they're going to do in the magnet room, or for a spouse or a parent that have to go into the magnet room to be with their child or their other family member. That's important to have those. With regards to inpatients, now this becomes much more complicated. I hear a lot of complaints that the nursing staff won't help. They make it very difficult, and I just am not sure why, because if they're engaged in keeping their patients safe all the time, I don't understand, but I guess it's additional work for them, and so it's tough, but you got to work with these people to make sure that you're a team and that they understand. And even though if they're going to fill out a screening form up on the floor, when they come down, then you need to go over it with them again very thoroughly to make sure that they clearly understood. If they're comatose, if they're unconscious or something like that, then you have to make sure that you have a personal physician or a family member, somebody who's who has knowledge of this patient's history, and you may also need to get very comfortable with checking for scars on the body as well to make sure that there might be some surgery there that you have to look into. And to check everything also before you go in the magnet suite, and I'll talk a little bit more about that, but to have checklists and so forth. Yeah, this was an example, and someone was just telling me about a very similar one. This was 3 MR techs, and a nurse from the floor brought the patient down, put them on the MR scanner table, went through, checked everything except the infusion pole here that you see that's in the magnet. It pulled the IV out of the patient. It sort of pinned one of the MR technologists to the front of the magnet. So I really believe in having a written checklist, not just something that people are eyeballing and trying to go on their memory, which is sort of the way it was when I first got to my institution, that all my faculty, MD and PhD, were just sort of using their memory, and it took me many years to get everybody into the swing of things, and they just automatically go for the screening forms now, which is a really good thing to remember. With regards to biomedical devices and implants, there's many kinds. You have to make sure that you understand they can be anywhere on anybody at any age, and you just cannot make any assumptions at any time. You have to have a very critical eye and ask lots of questions. These are sort of the risk of things. I think we tend to focus on this one. I know it's sort of the first one we think about. Will it get pulled out? But I think we also need to remember equally as important, even if it's not ferrous, even if it's not going to get pulled out, it can heat. And there have been a lot of burns. And I said earlier, I think this is really our problem in MR right now. We need to spend a lot of time focusing on this. I think for many years we've focused on B0, and we need to be focusing on B1. Of course, the risks are dependent on for the biomedical implants and devices. There's a large list here, and then I can go back and reinforce about making sure that your technologists are trained and educated and on an annual basis, that they attend meetings somewhere, or they get online training and it's regular and not just once. Because you have to understand all this, as does the radiologist or the medical director, and they've got to work together. So in order to ask the right questions, they've got to understand all these risks and how they're dependent. And it's quite a list, and but you have to go through all of them to make sure that you know what you're getting into. I know there have been times that my medical director, we've gone after an implant, thought, oh, it's probably this, whatever, and then we found out it wasn't. We found out it was something completely different. And it's times like that you have an aha moment. You go, okay, that's why I'm glad I have this list. And there's still lots of devices that are coming out that are fairly new and fairly recently developed, but they cannot go into a magnet. So we can't just assume. I know we see the things like the pacemakers, and it's great that people are trying to make these conditional, and so we can scan patients with them. But you've got to be aware that just because it's a new device doesn't mean they've taken into consideration that their patients will have to go into an MR someday. So you just have to remind yourself of that and make sure that you ask lots of questions of your patient, and you make no assumptions. We've had the patient that came in with the device we questioned. They'd had 10 previous MR scans, blah, blah, blah. When we went back and checked the records carefully, it was 10 previous CT scans. The woman had never had an MR scan in her life. So again, you really have to do your legwork, you have to do your homework, and it takes time. And that's why early screening is critical, so you have the time to do the best job, and you're not in a rush, and you don't have the surgeon breathing down your back to get the MR scan done. So this is some of the information that you'll need to look for, and that should be on the manufacturer's website of the device that you're trying to investigate. And be very careful that you do understand all this, and if it's not clear, call up the company. Make sure that they understand it needs to be clear, and you need to get some information from them, because I'm often looking on sites and it's not clear. And I know there's a lot of people now that are working more closely with the device manufacturers, and it's great, because it's really going to be helpful that we'll be able to get this information and that we'll be able to understand it. But it's, and so there's a lot of other information. And two, I'm always asking about what country, where was the surgery done, because they change around the world, and we're such a global society now that you have to be very careful, and you can't just assume because it wasn't done in your city or it wasn't done in your continent. It could be a very different kind of procedure. So how would the fixed parameter option basic, and I'm not sure if you've heard of this, but if you haven't, you should go here or Google it. But this is something that the scanner manufacturers and the implant device manufacturers are working on, and it's changing still. But it's in a nutshell, they would pick a set of parameters that with regards to RF and gradient and things like that you can control through your software, and there would be approved, their medical device would be approved for this, and then there'd be a button. I know it sounds too good to be true, right? And your techs would press the button, and then it would limit the SAR and things like that, and it would make it a lot easier. I'm not sure how quickly this is going to be put into production, but they really are talking about it, so I think it's going to be very helpful in the future. Obviously, things like magnetic field strength, the type of RF coil, things like that will not be helped like this unless it's going to rule out. I mean, that would be in a perfect world, right? If you had to use only a transmit receive coil and you were trying to use a receive only coil and that wasn't part of these parameters, then it would shut you down and say no. But at some point, we're going to get some help along this area, and I think it's really going to be great. So also with biomedical devices, and Manny referred to this as well, it really is the sole responsibility of the radiologist and the referring physician to decide if a patient with a medical device or implant undergoes an MR scan. I know there are facilities out there where the technologists are making this decision. If it's implants in the teeth, that's one thing, or root canals, that's one thing, but if it gets much more complex than that, it really needs to be the radiologist to make that decision. As I like to tell people, they don't pay me enough to make those kinds of decisions as to whether this aneurysm clip or whatever. I'll do a lot of the work to get the information as much as I can to provide to my medical director, and then based on his knowledge and a little bit what I know, but then we really do get the hard facts from the manufacturer to make the decision. But again, it's their decision. I also shy away from taking the drug patches off, too. I really don't want to interrupt drug therapy of any kind. Again, I'm not an MD, and so I really need to get my medical director involved and also the patient's doctor involved to make sure that we don't screw up his treatment, because they would probably have a real bad time with that. Preparation. Again, like I said, and I've said this, I keep saying this, I know there are facilities out there that don't change their patients. It makes me very, very nervous. Too many times people have been burned because there were things like the child that had the electrodes on their chest and they couldn't see them. You just have to make sure that people don't have things on their body. And if they've got something, like I like to say to them, in their body or on their body that they didn't have at birth, we need to talk about it. And I don't care how personal it is. There's some times I got a little embarrassed having to go to my medical director with some things people had in their body. But, you know, you've got to ask those questions. You've got to be comfortable getting personal, because it's your responsibility as well to make sure that the patient is safe. So change out of street clothes. Then you can focus on other things, not things that are in their pockets. You can focus on the really important things, the biomedical devices and implants that they might have. I know lots of people say they don't have space. We had a very small magnet suite put in, and we had to combine the bathroom and the dressing room, and now my medical director just thinks that's like the best thing, because he doesn't have to waste space on a dressing room and a bathroom, that we can just put them together. But anyway, it's really, really important. And then you can see things like electrodes. And again, this was another one that came out where a subject came over, he still had the electrodes on his chest, and this gentleman received a burn as well. So you just got to be up there. Oh, clothing, lovely. Probably, I don't know if many of you lived in the 70s. They had metal threads and clothing. Oh, I love those shirts. And now they're back, but I'm not happy about them now, because now you've got to look out for this stuff. Underwear, you can't really appreciate this, but this pair of underwear also had some silver threads in it, and the gentleman that was having a pelvis scan did receive some burns. And there's other undergarments that women are wearing that have metal stays in them. You have to be very careful. There's these little tags you see in clothing that you can see. They're an RFID. So if you're trying to steal this, the bell will ring as you try to leave the store. And that's why they tell you to remove them before washing. And there's some people who aren't removing them, and they have been burned by these things inside of a magnet. So very, very careful. And yes, I do. I check all the guys. You got any metal on your underwear? And they laugh, and then I have to explain to them, if it gets hot, you could get a burn, so we need to talk about your underwear now. And this you've probably seen in the news, and this cute little study that they did is that they're putting like a silver solution in clothing, so when you sweat, you don't smell. This started out with sort of the more expensive lines of clothing, but it's trickled down. It's everywhere now. This antimicrobial solution, and some people, I've seen it advertised in some of the magazines, and they're not really clear as to what kind of metal is in it, but as it's been explained to me, it's a silver solution, and these things are conductive. So you're going to have to be very careful. If you're still not changing people out of street clothes, you're going to have to be real careful with this because some people have gotten burned. This was loaned to me by Frank Shellock. This was a fiber burn from some of that clothing. So again, be very careful of this. If you have one of these systems, and I'm sure there's more, and that's great, I think they're great to have as an additional accessory as long as you're not using it as your primary screening device, that you still are using your forms and you're still talking to your scan subject. You have to be very careful with this thing. As I like to say, it's only as good as the people that are doing the screening. And the problem is we as human beings, I really believe, me too, I'm in there, I'll get lazy, I'll take shortcuts, and I will depend upon these things. And that makes me, right now, I'm sort of safe because at my research facility we don't have money to get one of these things, although we've been sort of talking about it, so maybe we will. But there are some other sites where, with the alarms going off, that the staff have become sort of desensitized to that, to this thing, and aren't paying as much attention to it as they should. So I'd be careful. Insulation and mobilization, I have a lot of interest in this area. Again, it goes back to B1, interest there, and I'll just go quickly on this. In talking to people anecdotally and also other people that have published, again, lead me again to believe this B1, the burns, the RF burns that we're experiencing is really our biggest problem that we're seeing. And as I mentioned, knowledge is critical for your technologists and also for your radiologists to make sure that they're spending some time keeping up, keeping informed. It's a moving target. It changes all the time. You've got to spend time reading and you know, just maintaining that knowledge that's changing, because you have to understand all these things. And if you don't, and Dr. Kugel showed that really nice slide about the different lengths and where they got hot, and if you could see at 1.5 T, at the 26 centimeter or whatever, that's where it got hot. And so technologists need to understand this, as well as the radiologists or the medical directors. A lot of people are scanning. They don't understand that when you're using a receive-only coil, you're transmitting with the body coil, and it transmits all the way along. It's not just transmitting in the head, it's transmitting all the way along. So any conductors, any cables that you have in there, you're at risk. You need to have adequate sponges and positioning devices to be able to insulate and protect your patients. You need to use these things on every single patient that you scan. Just get in the habit of it. Even if you're using a transmit-receive coil, use it for comfort. They hold still longer if they're comfortable. This is an old slide. I'm sure you've seen this. I was looking around for a newer one of someone that was burned, had their arms next to the bore, was not padded, and there was no other conductors in there, and this is the one Frank Shellock lent me. So it's out there. If you're letting your patients rest their arms against the bore, there was also a woman who was large-chested, and her chest was against the ceiling. She also received a burn. A lot of conductive devices that we have in there, a lot of cables. It gets more when you get into research, but even just in clinical, you have these in there too. You need to be able to insulate and make sure that they maintain position. This was a slide I put together because this actually happened at a facility that I knew about, where they ran the cable all the way around and put the ECG pads on the subject like this, and they did get warm. The subject didn't experience a burn, but that's like the biggest loop you could have inside of the magnet. So, I mean, this is the correct. You keep it away from the bore wall, you run it straight out of the magnet, and you insulate it from the patient to make sure that it doesn't taste the patient again. Because if it does, you induce a current, it runs into resistance somewhere, either where the electrodes are or if it touches the subject a second place, and then that's when you experience a burn. Dr. Kugel also showed about this, about there's being more emphasis about people being a conductor just with themselves. There was a story about a woman who was having a breast scan with her hand against her forehead. A breast scan, she was on her stomach, and she received a burn between her hand and her forehead. So you need to look into these articles. There's been several published now about where these points are, and you need to be careful about the scan subject experiencing this. This gentleman had his thumb against his thigh, and that caused a burn there. This gentleman had surgery on his thigh, and so it was much smaller than the other one, so when he put his legs together, only his calves touched, and then he experienced this burn here. So I get nervous because I'm in California, and as you know, we're all crazy, and don't wear any clothes all the time, and so I'm always trying to cover people up when they get in the magnet. This is another example of a burn that occurred on a subject where there was no conductors, no cables, nothing. And so there's still these burns that are occurring that we really don't know why they're occurring. And people follow up, and I know vendors follow up, but they still don't have reasons for why these things occur. And I'll just finish up with, I hope you're using your squeeze ball. I know some people don't want to use their squeeze ball with their patient because then they'll be disturbed by their patient. And then I wonder, I'm sorry, why are you in healthcare again? You know, they need to use a squeeze ball. They need to know they contact you if they're too cold, if they're too warm, if something's going on in there that isn't quite right. You know, and you've heard all the stories from your aunt went and she came back from her MR scan and wanted to know what the blue flashes were inside the magnet bore. Yeah, we do work with TMS, and we had a TMS coil go inside of a head coil the other day, and they were checking with their patient, and he said, tell me if anything you don't like, and that patient said, I smell something burning in here. So clear communication all the time. Make sure there's this clear communication, and that they need to know that you're a team, and you can't get your good images unless they're on the team with you, so they need to communicate with you. Thank you.